So today we're going to talk about percent, and you guys, for the most part at this point, I think are pretty familiar with the concept of percent. It involves taking the number of parts divided by the total parts um, of whatever it is that you're looking at times 100. So here's an example of a genetics experiment in which there are 25 flowers that are red, 33 yellow flowers, and 22 white flowers. And the goal is to find the percentage of each of the flowers. So you need to do some simple math here because you have to get a total. And once you have the total, then you can use the equation, the percent the percent of a specific thing is divided by however many parts of that thing there are divided by the total parts. So with mass percent, and this is where I am going to start writing some chemistry stuff. With mass percent, there are two ways that we can, two ways to do calculations. And the first way is using lab data. And the second way is using a chemical formula. And I will go through an example of each of these, and then I'm gonna cut you guys loose to work while I stay in the Zoom meeting. So two ways that we can calculate. The first is using some lab data. This is an example where we might not know what the actual formula is of a substance that we're making in the lab, but we can look at how much of each thing we have and we can get to that formula. This is an empirical formula calculation, which is a later lesson. So this is mass percent using lab data. And here, sometimes you really need to sort through what it says. It says a sample of nickel oxide is composed of 14 grams of nickel and 7.64 grams of oxygen. So the nickel oxide is the total, and the individual parts include 14 grams of nickel and 7.64 grams of oxygen. So in order to get percent composition of each element, we need to come up with the total. So our 14.00 grams of nickel plus our 7.64 grams of oxygen gives us 21.64 grams as a total. So sometimes you might be given the mass of each element and you have to calculate the total, but this problem could have been written another way. And after I get done with this, I will give an example of how it could have been written another way, because there is an example like that in the assignment. I believe it's the first one. So to get the percent nickel, I have to take my grams coming from the nickel, which is 14.00 grams, divided by the total, 21.64 grams times 100. And to get the percent oxygen, I need to take my total for the oxygen, 7.64 grams, divided by the total for the entire compound, 21.64 grams times 100. And I'll do this in my calculator. 14 divided by 21.64. I'm a superstar today. I'm doing this without my cheaters. The calculator says 64.6 0.695%. And then I have 7.64 divided by 21.64 times 100. And I get a 35.305%. So here we're looking at about a 65% nickel and a 35% oxygen. By practice with percent composition problems, I like to typically round this out to 2 places past the decimal point. For some reason, mass composition percent problems don't fall within the rules of sig figs. If they did, we would round this to 64.70%. And because this 7.64 has 3 sig figs, we would round this to 35.3%. And it ends up being the same. They both add up to 100. So an alternative way that this problem could have been asked would be, they could say that 14.00 grams of nickel reacts with oxygen to produce nickel oxide that has a mass of 21.64 grams. So they might tell you the mass, the total mass, and you have to work backwards and calculate the oxygen. So this, in the assignment that I have for you today, this is what you have to do for that assignment. So let's look at the next way that we can calculate. I lost a slide. I clicked on the wrong one. Here it is. I was working in the wrong PowerPoint. We'll figure. Here's the second way. We use a mass percent calculation using a formula. So in this case, we have a formula, MgCO3. We have to identify what elements are there. We have Mg, which is magnesium. We have C, which is carbon. And we have O, which is oxygen. So I'm going to identify the elements. So I have 1 magnesium, I have 1 carbon, and I have 3 oxygens. Now what I need to do is I need to use periodic table mass data to get a total mass for this compound. So the mass of magnesium is 24.31. The mass for carbon is 12.01. And the mass for oxygen is 16.00. And so I'm just going to remind here that this is mass values from the periodic table. So I will get a total because I need to have a total before I can get a percent. 24.31 plus 12.01 plus 3 times 16 happens to be 48. That can't possibly right. I got 600 as my number. 24.31 plus 12.01 plus 48. I get 84.32. And let's just call it grams. So my percent magnesium is going to be 24.31 grams divided by 84.32 grams times 100. My percent carbon is going to be 12.01 grams divided by 84.32 grams times 100. And my percent oxygen is going to be 48.00 grams divided by 84.32 grams times 100. I'm going to pick a different color to put these answers in. 24.31 divided by 84.32 times 100. Just do these questions, do these quick. I get a 28.83%. 12.01 divided by 84.32 times 100. I'm probably making mistakes. That is common. I punched the wrong things in the calculator. If these end up adding up to 100 when I'm done, I know that I didn't make any mistakes. I get a 56.93 plus 14.24 plus 28.83, and that gives me a number very close to 100. So I just, your final percentages should all add up to 100. So that is how you get a percent calculation using a formula. So I'll show you the assignment. It is in Schoology. There are two versions. One is in which all of the problems are together, and you can answer them on a piece of paper and take a picture. I prefer that you scan it and have it be in the form of a PDF. Or you can click on this PDF, and if you have a printer, you may print it. This will end up being 2 pages, and you can just answer the questions on the paper. So I would like you to answer them in the same way that I did in my demonstrations. The first one is an example that I was talking about. It says that a piece of iron has a certain mass, and it gives you the total mass of the iron oxide. So you need to actually retroactively go back and get the mass of the oxygen in order to solve this problem. And I don't know when I have this assignment due. I don't know, it's on there. But I would like you to have the other one done by Monday. We will be taking a quiz, and I'll remind you of that tomorrow. We'll be taking a quiz on Monday of significant figures, sig figs and calculations, and also some unit conversions. So if you have questions, you're welcome to stay on. I will continue to be here. I'm going to run to the bathroom super fast, so I might not be here if you need to be readmitted, but I will be here for questions after about 3 minutes. So you're welcome to stay on. I'm going to run to the bathroom, or you can go out, come back in if you need to. I'll be back shortly.